Alright, let's try some slightly tougher examples now. How about this one? On January 16th, you had 100 Twitter followers. Since then, at the end of each month, you check how many followers you have, and at the end of each month, you have 18 more followers. Now, this is extremely similar to an example we did before, but this time, instead of starting with 0 followers on January 16th, now we're starting with 100 followers on January 16th. Now, our dependent and independent quantities are going to be exactly the same. The dependent quantity is going to be the number of Twitter followers you have, and let's call that variable y. Our independent quantity is going to be the number of months since January 16th, let's call that x. Now, recall from our original example, when we started with 0 followers, here's a table of values to show that relationship, and the equation was y equals 0 plus 18x. That 0 represents how many Twitter followers you had on January 16th, 0 months since January 16th, and the 18 represented how many more followers you got each month. Now let's create a new table of values for this new relationship where the number of followers you have still goes up by 18 each month, but you start with 100. Alright, now that we have this new table of values, why don't you pause the video and see if you can come up with a new equation to describe this relationship. In this case, our equation is going to turn out to be y equals 100 plus 18 times x. The only difference in these two equations are that 0 plus 18x became a 100 plus 18x, because the only difference in the relationship is that we started with 100 followers on January 16th, but the number of followers still increases by 18 each month. Let's break down this equation a little more and talk about some of the different elements in it. 100 represents the starting number of followers on January 16th, or 0 months since January 16th. The 18 represents by how much the followers increased each month. The 18 times x represents the total increase in followers, right? 18 followers per month times however many months it's been. And of course, 100 plus 18x represents the total number of followers you have. The domain for this new relationship is actually going to be the same as it was before. The possible number of months are 0, 1, 2, 3, etc., etc. The range now, the possible outputs, the possible number of followers you have is going to be 100, 118, 136, 154, etc., etc. Now in this example, we randomly chose to start with 100 followers, and we randomly chose to have those number of followers increase by 18 each month. But I want us to be really good at creating these equations and finding the domains and ranges for any possibility that gets thrown our way. So let's try 2 more really quickly. What would the equation look like if we started with 170 followers on January 16th instead of 100, but they still increased by 18 each month? Why don't you pause the video, try to come up with that new equation, the domain and range on your own, and then play the video and we'll see how it went. The only difference in the equation here is it's going to be y equals 170 plus 18x. The number of Twitter followers is still growing by 18 each month, but we start with 170 when x equals 0, when we're on January 16th. The domain remains the same, 0, 1, 2, 3, etc. And the range in this case is just going to be 170, 188, 206, 224, just adding 18 each time again. Let's try one more. What if we started with 50 followers on January 16th, but the number of followers increased by only 8 each month now? Once again, why don't you pause the video, try to create an equation, and find the domain and range for this new relationship. In this case, since we started with 50 followers and it increases by 8 every month, our equation is going to be y equals 50 plus 8 times x. The domain remains the same, 0, 1, 2, 3, etc. And the range in this case is going to be 50, 58, 66, 74, going up by 8 each time. A reminder that if you're ever having trouble creating these equations, it's always a good idea to make a table of values and then check your potential equation against it. I find that it really helps me. After these last few examples, I hope that we see that there's definitely a pattern developing, and a lot of our modeling is going to revolve around these sorts of situations where we have our dependent quantity starting at some number when the independent variable equals 0, and then increasing or decreasing by the same amount every time the independent quantity increases by 1. So let's keep that in mind as we tackle a few more. On October 5th, a viral YouTube video had 400,000 views. At the end of each subsequent day, it had 10,000 more views. Again, this is extremely similar to one we did before, but in our previous example, the YouTube video had 0 views on October 5th, and now it has 400,000 views. The independent and dependent quantities we used before are going to remain the same. Let's use, for a dependent quantity, the number of views in thousands. It'll make life a lot easier. Now, here's the table of values for our old relationship, and here's the equation for our old relationship, starting with 0 views on October 5th. Now that it starts with 400,000 views on October 5th, why don't you try first to make a table of values for this relationship, and when you're done with that, why don't you try to make the equation too, and then we'll reconvene to discuss. Alright, so the difference here is that we're starting with 400,000 views on October 5th. Now note, we're increasing by the exact same amount as before. That's why this 10 remains the same in each of these two equations. Again, I'd like to quickly dissect this second equation that we just came up with. The 400 represents 400,000, which is the starting number of views on October 5th when our independent variable is equal to 0. 10 represents 10,000, which is by how much the views increased every day when our independent variable increases by 1. 10 times n represents the total increase in views. 10,000 more views per day times n, the number of days since October 5th. And of course, 400 plus 10n represents the total number of views, which is of course r. Our domain doesn't change in this case, it's still 0, 1, 2, 3, etc., etc. And our range is just going to be all the possible number of views. So in this case, 400, 410, 420, which of course represents 400,000, 410,000, etc., etc. Again, I want us to be rock solid on coming up with these equations for any given scenario. We randomly chose 400,000 views to begin with. We randomly chose 10,000 more views per day. I want to give you 2 more examples and see if you can come up with these equations on your own. Remember, I always suggest making a table of values first. So, what about if we started with 720,000 views on October 5th, increasing by the same 10,000 views per day? Or what about starting with 250,000 views on October 5th, increasing by only 12,000 views each day? Why don't you try creating the equation and finding the domain and range for these 2 relationships, and then playing the video to see how it went. Alright, 2 more examples for you to practice with. For each of these, once the hypothetical situation is laid out, please pause the video and come up with your dependent and independent quantities, give them variable names, create a table of values, an equation, and find the domain and range for each relationship. Alright, on February 7th, you purchased a used car with 38,000 miles already on it. Since then, you drive it consistently throughout each month and you put on 2,000 more miles over the course of each month. 2 things of note. First, the domain and range. Since this relationship could be best described with a continuous graph, a connected graph, our domain and range are not just going to be lists of individual numbers, they're going to be intervals, so they're best captured by inequalities. In this case, the domain g is greater than or equal to 0, and the range q is greater than or equal to 38,000. Also note that if you wanted, you could change how you defined the dependent quantity to be miles in thousands, in which case the equation would be q equals 38 plus 2 times g. The domain would be the same, but the range would be q is greater than or equal to 38. Alright, last example, and something slightly different in this one. On January 11th, your savings account had $12,000 on it. Since then, it decreases by $300 each month because you have needed to take out $300 at the end of every month to pay your bills. Big difference here, that quantity is decreasing. Already, I'll tell you that our dependent quantity is going to be the total amount in the savings account. Once again, please pause the video and play it again once you've taken care of everything. Alright, the big difference here is that since the amount in our savings account is decreasing, our equation is going to be P equals 12,000 minus 300 times A. Because we're taking away from our savings account, that's why we're subtracting in this case. The 300 still represents how much our savings account is changing at the end of each month, but of course it's decreasing, and that's why we're subtracting instead of adding. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.